Okay, hi everyone. I'm Leo Ponomarev. I'm a freelance full-stack web developer by day, and by night I tend to write C. So I'm also the author of Nchan, and I'm going to be talking about some of the things I learned while working on it. Specifically, I'll be covering how to get your C code to talk to Redis, how and why you might want to use Lewis scripts, how you might want to format them, how to test them, how to embed them, how to debug them, and I'll also be sharing some tools that I made along the way that streamline that process. So first, I'm just curious. So how many of you use Nginx somewhere in your infrastructure? All right, that's a lot of people. Okay, and how many of you use like WebSockets or event source or some kind of a server push technology for your front-end clients? Okay, a little bit. Okay, all right. So this part is sort of for you guys. So Nchan itself is it's a module for Nginx. It's a pub/sub server for web clients like event source, like WebSocket, long polling, a couple of others. So you can use those to subscribe to channels, and you can publish to channels with HTTP post requests and with WebSockets. The messages are buffered, so old messages can be received by new subscribers. The messages are stored either in memory or on disk, depending on how large the message is, or you can also store them in Redis. Just a bunch of features of Nchan. So the channel IDs themselves are derived from the incoming request. So it can be part of the request URL, or maybe it can be part of the query string. It may be part of the header. That's entirely configurable. And the buffers themselves are configurable per channel. Each subscriber can subscribe up to 255 channels, and that can be increased to more later. There's access controls for each channel to prevent like denial of service attacks, things like that. And the subscriber connections themselves are resumable, so if a connection gets interrupted, you can resume it later because messages are delivered with a message ID that can be used for that purpose. Scalability, it scales pretty well. It is part of Nginx, so it handles open connections just as well as Nginx does, which is really well. Just in my benchmarks, you can get 30,000 WebSocket responses in about a tenth of a second, and that's on 5-year-old hardware. It can be scaled up basically with better hardware vertically. If you want to scale it horizontally, you'd have to come up with some kind of sharding scheme if you want to scale it past one Nginx instance, or you can just use several Nginx servers and connect them to Redis. Okay, so before I get to the Redis stuff, I want to cover just very basics of how Nginx is configured and how you configure Nchan inside. So over here I have a pretty basic simple config. So there's 2 locations that are matched for incoming requests, one for a subscriber and one for the publisher endpoints. So let's say we have an incoming GET request. In this case, I'm running curl to do it. What this will do, so this is subscriber to sub/foo, which would match that first location. The channel ID would be derived from the part of the URL, that's the regular expression capture in there. So that would be the subscriber, and this would be treated as a long polling request, which the way that works is that essentially hangs until a message is available on that channel. So let's say there are no messages in the foo channel, so next let's publish a message. We'll do that with a post request to pub/foo, which same thing would happen. That would match the publisher location. It would set foo as the channel ID, and once that gets processed, the message is sent to the subscriber, and the publisher receives a little bit of metadata. So a little bit of history. This is originally a fairly old project at this point. I started in about 2009. It used to be called the Nginx HTTP push module. Only supported long polling. The concurrency model wasn't that great, but it worked well enough for the time. And I put it aside for a while, and then about 3 years later, I had some more time to work on it. I did a lot of refactoring. Then I went into kind of crazy refactor mode last summer, added a whole bunch of features, added Redis support, and renamed it to Nchan, because saying Nginx HTTP push module every time was kind of a mouthful. All right, so I'm going to do a bit of a sort of a bird's eye view of architecture stuff with some whiteboard drawings here. Nginx is a multi-worker server, so requests come into different worker processes, and each one handles the incoming requests. That's up to the operating system which one handles it. Within each of those, Nchan has a memory store, the mem store, and the channels in it are stored in hash tables. The workers talk to each other with some inter-process communication. The messages themselves are stored in shared memory. And the channel ID namespace is sharded out between the actual workers. I do this to avoid concurrency problems when dealing with shared memory. All right, let's get to Redis. Let's say I have an Nginx instance with just one worker. So within that, I have two structures, the memory store and the Redis store, which have separate hash tables for channels. So let's see what happens if I subscribe to it. So, okay, so some subscribers arrive at channel ID 1. Memstore creates the channel, forwards it to the Redis store. That in turn creates a pub/sub subscribe connection to an associated pub/sub channel in Redis. All right, so publishing. Let's say a post request comes in, that gets forwarded to the memory store. A message gets created in shared memory that gets sent to the subscribers, gets forwarded to the Redis store, which in turn runs a Lua script on the Redis side, which creates some data in Redis, and it also forwards that data encoded as in message pack to that pub/sub channel. So of course the purpose of using Redis here is horizontal scaling. So more than one Nginx process can be running subscribed to the same channel. So this is what happens when another Nginx server receives that message. So first the message comes in through the pub/sub channel into the Redis store that forwards it to the memory store, which creates a message in shared memory and dumps the message to the subscribers. So that's how that works. Here's what the data looks like on the Redis side. So there's basically a channel. The channel is stored as a hash. The messages themselves are also hashes, and they're linked to the next and the previous message so that they can be traversed easily. And I also keep a list of message IDs to keep track of how many messages there are per channel. Oh, and there's also the pub/sub channel that workers receive publish notifications on. Okay, so that's basically the bird's eye view of it. Now I'm going to get a little bit into the trenches. Okay, so Nchan uses the Hi Redis client to talk to Redis. Nginx itself has a custom event loop, and Hi Redis out of the box supports a couple of standard event loop libraries. Nginx isn't one of them, not that you'd expect it to be. Fortunately, I didn't have to write the event loop adapter from scratch. These fine folks have done most of the work for me. I just had to do a little bit of debugging, combine their code to get it running nice and smooth. And I ended up having to have 3 separate connections from each worker to the Redis server. One is for running scripts and running commands. One is for subscribing to the pub/sub channels. And there's another one I use, a synchronous connection, the other 2 being asynchronous. And the synchronous connection is for use when Nginx is shutting down, the event loop becomes kind of unreliable, so I want to make sure some commands get through. So that's what the synchronous connection is for. So I use a lot of Lua scripts, and they're great to cut down round trips, and they're great to do like data handling logic, especially if the rest of your project is in some low-level language like in C. But it's got some drawbacks. There's really no way to call scripts from other scripts because you have to know their hashes, and if you're developing the scripts, the hashes are going to keep changing, so you need to keep changing the hashes within the scripts, or you need to pass the hashes of other scripts as parameters to other scripts. It gets kind of messy. So there's really no way to share functions or to reuse code between the scripts, which presents sort of a dilemma, and basically means there's 2 particular ways to structure Redis scripts, to structure Lua scripts, that is. So the first approach is let's say you need to implement a couple of commands with scripts. So one approach is to have all the commands that you need to implement, dump them all in a single script, and run the command that you need as a parameter that you pass to the large script. One good example of this is the GeoLua library, which I guess they haven't talked about yet, but it's like an enhancement to Redis 3.2's new Geo API. I'm not entirely familiar with it, but I know that's essentially how it's structured. And it's the only way to reuse code within Lua scripts, but it can get pretty large, so it's a little hard to write, and it's a little hard to debug because lots of code in one big script. It's gotten a little easier these days now that we have the command line debugger. But I encourage everyone to use it, by the way. It's great, but there are some drawbacks with this approach. So anyway, the other approach is having each command that you need to implement gets a separate script. It's nice when there's not a lot of overlap in the code that you need for each type of command that you're implementing. I find it easier to work with smaller scripts. The code can be a little more modular if there's not a lot of overlap. But for the overlap that is there, you're going to have to copy and paste or something. That part isn't really pretty. Anyway, so here's just a snapshot on the right of the the scripts that I use, and just a little bit of the code for Nchan. So I ended up using the option number 2, splitting scripts. Basically, I'm using the scripts because I can take out a lot of the data handling logic that I would otherwise have to do in C and just do it in Lua. But before adding this stuff into actual C, I wanted to make sure that that the scripts actually function pretty well, because it's kind of hard to debug from within C. So I needed a way to test stuff, and then I also needed a way to embed things. And those are the two sort of helper scripts that I ended up writing, which I'm going to go into. Okay, so for testing, I had a Ruby harness to set things up, and I'm not going to go into the actual tests, but just 2 things of note here. I have I use a Lua-P, the Lua compiler, in parse mode before loading the scripts, and that just gives me like a syntax check before the scripts are actually loaded as a sanity check, essentially. And also, when loading the scripts themselves, if there's an error, I output the name of the script along with the error with the script, just so that it's easier to develop. So at this point, I was basically ready to. Okay, so all my scripts are well tested enough. I mean, they still had a couple of bugs, but they're well tested enough to be embedded in C, and so that was my my next step, the next problem. And embedding gets a little ugly. So on the left of here I have the find channel script, just one of the scripts that I'm using. And on the right is what it would look like embedded as a C string. I myself much prefer working on the nice syntax highlighted version. And also there's a problem of error handling from within C. So that on top over there is what the standard Lua script error looks like. So one nice thing about it, it's technically not part of the spec, but it's in there. The hash of the script is available in the error message, so that could be used to look up the script name. So if I want to embed scripts into C code, it's probably a good idea to embed the names and the hashes along with it. So that's exactly what I did. I had a little glue script that took in a bunch of Lua files, and it output basically a C header with the source of the scripts, the hashes, and the names of the scripts. Then I thought this was pretty useful, so I decided to get a little fancy, and I wrote a Ruby gem for it, and that's the hash-safe script splinterer, otherwise known as HISS. It's got a bunch of options. I'm going to go through them. So it also runs Lua-P to run a syntax check on your scripts before processing them. There's a little caveat that Redis uses Lua 5.1, and your system might have 5.2 or 5.3 installed. 5.3 syntax is a little more permissive. There are things you can do on one line that you can't do in 5.1, but it'll catch 99% of syntax errors. So the variable names and the structs that are outputs are all customizable. There's an iterator, which I'll go into, and there's different output formats. So these are the two different output formats for those example scripts that I had earlier. So on the left, I have the whole, so I have the whole format, which outputs basically one variable which contains a named array of structs with a bundled name, script hash, and the script source. And I also have the split format, which outputs 3 separate variables, each of them being one is for the hashes, one is for the script names, one is for the script sources. It's basically up to you which one you prefer. I prefer the whole format. I wrote the split one first, but it's up to you how you want to use it. So here's how you go about loading the actual scripts. So I use the iterator macro that his provides. That's the Redis Lewis scripts each right there. And within the iterator macro loop, I run a script load command, pass the script source as a parameter to the script load command, and as part of the private data, I include the script struct, and there's also the load callback. And within that callback, it's because I need to make sure the script loaded successfully. Otherwise, you've got errors, and you're running stuff in C, and your script has failed to load, and you don't know what's going on. So you need to be very aware of what your scripts are doing when you're loading them, especially. So if there's an error while loading, I just output the error along with the script name, because that was passed in as the private data to the command. And also, just to be on the safe side, I check the hash of the script just as a sanity check to make sure it's what I was expecting it to be. So here's how you actually use it. If you're running the whole format, if you want to run a script, you run your eval-shock command, and for the hash of the script, you pass the Lewis script variable .name of script .hash. If you're using the split format, it's pretty similar. It's the script hashes variable .name of script. And of course, when you're running commands, you want to have some kind of callback, and you want to do some kind of error handling. And so I have a sort of a generic error handler for that. So once again, recall that the error, the Lua error, looks something like that at the top. So that means if that string is found, if error running while script call to f underscore is there, that means we probably have a script error. So then we can take out, extract the hash from the script, from the error that is, run the script iterator, see which script actually made the error, and then output the error along with the script name. This is just, again, to make development a little easier. Okay, so HIS works very nicely with build tooling. You can put it in a separate script if that's how your build process works, or you can add it to your makefile if you want. I'm not going to go into the details of that, because you can check that in the talk notes later if you want. So then I decided to have a little bit of fun with it, and I thought, well, Redis has some embedded scripts, so wouldn't it be nicer? So this is just some embedded scripts in scripting, in the scripting part of Redis. So I thought it'd be nicer if instead of that they looked like that, if they were separate files. So that's exactly what I did. I took those C strings, I extracted them into separate files, edited the scripting C file, added an include for lewisscripts.h, which is where the HIS output is generated, and instead of loading the C strings directly, I'm basically loading the scripts by name. Modified the makefile, added a little rule to generate the scripts, to generate the embedded file, and so basically, this makes it possible to basically work on Redis, just for an example here, on Redis, and modify scripts when you need to, and they'll be auto re-embedded and you don't ever have to worry about C strings. So here it's building after deleting the actual output there. Okay, so scripting just got rebuilt, which called his with a bunch of parameters. For Redis, you don't actually need hashes, you don't need script names, you just need the raw output, the raw script sources. So if you rebuild it again, nothing happens. If you touch one of the scripts, it rebuilds and regenerates just like a normal sort of makefile process would. If you add a syntax error to one of the scripts, it'll error out. If you take out that error, it'll work fine. And the nice thing about it is his is actually not a dependency for just building it. It's a dependency only for development because it'll only get called when the scripts actually change. And here's what the output actually looks like. You can see, I don't know if you noticed, there's the comments from the scripts themselves are pulled out to the top, so you can use the generated file sort of as a reference. Okay, that's his. You can run it. You can install it with gem install his. It's all on GitHub. It's customizable. It's got an iterator macro. You don't need it. You only need it for development. You don't need it for distribution. And while talking about it, you sounded like an angry cat. All right, moving on. Okay, so debugging. So in 3.2, we now have the command line debugger, which is very nice. And it's great for actually putting the scripts together. However, if your scripts are running from within C, you're not running them from the command line. So you need to do some other form of debugging, and really the only thing available is some kind of output. So there's different ways to do this. You can log to the Redis log. You can use Lua's print functions to log to the console. You can output debugging messages to some kind of structure, to a list maybe. But my preferred method is to use Redis CLI, a dedicated Redis CLI monitor, as well as calling echo from your actual scripts. And here's why. So here I have the monitor output for Nchan debugging session. This is basically a subscriber subscribed, and then I published a message to it. So just looking over it, you might notice that I have these sort of highlighted echo statements. So these are lines that I include at the start of every script. It's essentially the first command run, and that means that the line right before it in the monitor output contains all the parameters that the script was run with, and there's also some miscellaneous debug output. So that's the reason I prefer the monitor output to all the others is you get to see all the script parameters that it's called with, and you also get to see all the commands that the scripts are executing. And as long as the scripts themselves are marked very visibly, so that the eye is kind of drawn to it when you're looking at the output, it's also really easy to see which scripts are actually running. And of course, you can grep through the output if you need to zoom in on some particular script that you need to be debugging. Okay, if you're going to be doing a lot of output from Lua scripts, it's useful to have a general purpose output function that doesn't basically error out. One thing about Lua is if you're outputting strings and you pass something that isn't a string, it's gonna freak out and you'll get an error from your debugging output function. So what I do is I coerce everything to strings before outputting, because Lua only coerces numbers. Lua only coerces numbers to strings. Everything else will give you an error if you try to output it. So you can use something like this in your Lua scripts if you want to do output. This is all in the notes later if you want. So basically, that's how I have Nchan put together. It's essentially a collection of scripts that perform all different functions that you'd expect a message store essentially to need. I actually only use scripts, I think. The only 4 commands I run, I think, From C are load script, eval SHA, subscribe and unsubscribe. I don't actually call any commands directly, any data altering commands from C. Okay, so here's what a couple of the scripts look like. The source is there just for reference as to how large they are. So subscribe, there's a subscribe script. It updates subscribe accounts, does some stuff with IDs, and manages key expiration. There's a publish script, quite a bit longer. I really wish I had the command line debugger for this one, but unfortunately I was working on this last summer, like in July, August, and the debugger came out, I think, in September, so I didn't get a chance to use it. So it stores the messages in Redis. It gets rid of old messages, garbage collects messages that have expired, and it also sends the publish to the pub/sub channel, and that's encoded in message pack. So there's a delete channel script, deletes channels and all its associated keys, and also sends a pub/sub notification. And there are a bunch of odds and ends that optimize stuff. Not terribly important. So, okay, so I mentioned earlier that a lot of the Redis modules, a lot of the Nginx modules don't use the Hi Redis client, and I think I know why. Hi Redis, when you use it to run commands, copies all the parameters that you pass to it into an internal representation. I looked at the code; it actually copies it 3 times. So if you're running commands with very large parameters, there's going to be some memory churn. It's going to need to be copying it over and over. So if I want to squeeze as much performance out of this thing as possible, I might need to add maybe some kind of a parameter that doesn't copy, that reads directly from memory. I actually started working on this on the flight over here, but I don't know what'll come of it. We'll see. On the Redis stuff, the Nchan stuff that's related to Redis, I need to add the ability to connect to multiple Redis servers, because right now several Nginx instances can be connected to a single server, but you can't have connections to different Redis servers from within one Nginx instance for like different channels, for example. And the big one is I still need to add cluster support, because that'll make it scale like crazy. And I'm actually looking maybe for some support on this, maybe if anyone's interested, contact me about that. Okay, so if you want to try Hiss, it's you can. If you need to embed stuff in C, it's gem install Hiss. The code is documented on GitHub. If you want to see the Redis fork that I had up there, that's also on GitHub. If you want to give Nchan a try, everything is documented at nchan.slack.net. You can try it out on your Macs. There's a homebrew package available for it. You can build it from source. I have packages for Debian, for Ubuntu, I think for Fedora. Yeah, I think that's about it. I got notes for these slides if you want to look at the source for anything I've mentioned. My GitHub page is up there. If you want to support Nchan development, I take PayPal, Bitcoin, and that about wraps it up. Thank you guys for coming. Got any questions? Yeah, go ahead.
Amazing presentation, and I really interested in this part, specifically like Lua scripting and Lua embedded like in Nginx and Redis. So first question, I guess, have you ever tried to use Busted for Lua, like Lua test framework for your scripts?
No, I'm not familiar with that.
Okay, as contributor, I highly advise that.
Okay.
Perhaps that's better than using like Ruby for these things. So second question, have you ever tried to use like Moonscript as embedded?
To use what, I'm sorry?
Moonscript.
Not familiar with it either.
Okay, so Moonscript is basically something that translates pretty much similar like to Ruby syntax into Lua, and then compiles it, and you can run it.
Okay, I see.
So,
would you be able to use? Question to you. Would you be able to use Redis commands from within Lua through Moonscrape?
Yeah, of
Okay,
course.
okay.
Moonscrape, it's just basically like for JavaScript, and there are a few
Okay,
compilers.
so it's a transpiler, basically.
Yeah, exactly,
Okay,
transpiler.
Gotcha.
Well,
Okay.
so like my question was like, do you have any experience, and have you ever tried this like with?
No, I like working with Lua, so I stick with it.
Okay, thanks.
Any more questions? No? Okay. All right, well, thank you guys for coming, and I hope you had some fun. Thanks.